All right, it's the beginning of a new unit. It's called Compound Inequalities. And we have compound means two or more. Compound, just like a compound word, like homework is two or more words. We have two or more inequalities. Steps are solve both halves of the compound inequality. That means there's two of them. Both means two. Sketch each one of the solutions on a number line. If they point towards each other, awesome job. Fill in the region between the circles. And here we go. Solve each compound inequality and graph its solution. Here's two examples. This is what they look like. They are either separated by the word and, such as this one is, or they're written together and they have inequality signs that are less than or equal to's. That's how you know you are dealing with and kinds of compound inequalities. Alrighty, says solve both halves, and we shall. Here we go. How to solve? Well, here's our two inequalities, and we just solve them. So we've got negative 10b minus 2b is greater than or equal to 6. Combine like terms, they're both v's. So negative 10b and negative 2b gives me negative 12b is greater than or equal to 6. We need to divide both sides by negative 12. Divide both sides by a negative 12. Remember, when you're dividing by a negative number, you have to flip the direction of the inequality. And now we have v is less than or equal to 6 divided by a negative 12 is simply the fraction negative 1/2. The second inequality on the right-hand side is 6v plus 12 is greater than negative 6. All right. Let's see. So we would need to subtract 12 on both sides on this one. That goes away, and we have 6v is greater than negative 6, and negative 12 is a negative 18. Divide both sides by 6. We're not dividing by a negative number, so we continue with the same inequality sign. And this is v is greater than a negative 3. How to graph? Well, we've got two parts to this inequality. Put the most important numbers on your number line that you need. Negative 3. I'll put a negative 2, a negative 1, and a 0 because negative 1/2 is in between 0 and negative 1. So negative 1/2 is right about there. It says b is less than or equal to. Well, we've already learned if it's less than or equal to, it has a solid dot, and the numbers that are getting smaller is going towards the negative 3. This side says v is greater than negative 3. Since there's no equal to part, we have an open dot, and the numbers are getting greater going towards the positive side. And you can see that these are intersecting between the two dots. Whoops, I kind of in this one. Sorry about that. Get an open dot a little bit better. And these are going towards each other. So this is what most and inequalities look like. Most and inequalities. That negative 1/2 looks terrible. Alrighty, the next version is when they are written together. We have two inequalities, and we might need to separate them so that we can solve them. Well, one part of the inequality is this part, and then the other inequality still has the middle part, but we would include it on the right-hand side. So to write them individually, we would have negative 36 is less than 3p minus 6, and the other one, which is green, is 3p minus 6. Notice they have this section in common, is less than or equal to negative 15. And here we go. We still want to isolate the variable, which happens to be p in this case. So we would add 6 on both sides. Negative 36 plus 6 is a negative 30, less than, and these just go away, and we have 3p. Divide both sides by 3, and we have P is greater than, negative divided by a positive is a negative, and that would be a negative 10. Now, when we graph, we have to have the P come before the number. So we have to rewrite this inequality, but we have to maintain the integrity. We have to keep it true. So if the open part in this case is facing the P, the open part still has to face the P. And the pointy part is facing the negative 10, and it still is. But this is the direction we need to graph it. Going to the second inequality. The steps are the same. We need to add 6 to both sides, and you'll notice that's what we did over here. We added 6 to both sides. This leaves us with 3p on the left-hand side, and negative 6 or negative 15 plus 6 is a negative 9. Divide both sides by 3, divide both sides by 3. Once again, if you look over here, that's exactly what we did. And we have p is less than or equal to negative 3. So we will graph these. Negative 10 comes quite a ways before negative 3. This one says p is greater than negative 10, so an open dot, and going towards the positive numbers, that's where things are getting greater. This one says p is less than or equal to, so we have a solid dot, and the numbers are getting less than, going this direction. Once again, we have the two dots and their intersecting section in between. So that's the way most inequalities that are ands are graphed. More examples. All right. Both of these are written separately, so we can just start to solve them. Negative 10b and negative 2b is a negative 12b. Greater than or equal to, whoops, I forgot my b, sorry about that. 6. Divide by a negative 12. Divide by a negative 12. Flip the sign, and we have b is less than or equal to negative 1/2. We had that before. In fact, we've had this entire inequality before, so we should be able to get this real quick. So minus 12 on both sides, minus 12 on both sides, and we have 6b is greater than negative 18. Divide by 6, divide by 6, and we have b is greater than negative 3. So we would have a negative 3 somewhere down here, a negative 1/2 somewhere here. V is less than or equal to negative 1/2, so a solid dot, arrow's going this way. V is greater than negative 3, open dot, and the arrow's going this way. We had that just above. The second one is a little bit more interesting. The first thing we have to do when we have equations that have an expression on top of a division by a number was actually multiply by the bottom number. So we will multiply both sides by 4. That just gets rid of the 4 on the left-hand side and leaves us with 4x plus 8 is greater than negative 2 times 4 is a negative 8. Subtract 8 on both sides. That goes away, and we have 4x is greater than negative 8, and negative 8 is a negative 16. Divide both sides by 4. And we have x is greater than a negative 4. Negative 16 divided by 4 is negative 4. Then we have the second part of the equation, or inequality. Subtract 4 on both sides. That goes away. 7 minus 4 is 3. So we have 3 is greater than 3x. Divide both sides by 3. That's 1. So we have x, and this is also a 1. X is less than 1. But once again, this is written incorrectly, so we need to have the x in front. The pointy part is towards the x right here, so it has to be towards the x in the second rewrite. Open parts towards the 1, and the open parts towards the 1. So the two most important numbers we need is a negative 4 and a positive 1. X is greater than -4 is an open dot going towards positive numbers, and X is less than 1 is also an open dot, but this time is going towards the negative numbers. And once again, you can see that it intersects between the two dots, and that is the way most and inequalities are graphed. Okay, we'll do the next two examples real quick. These are both written all together, and number 3, I believe, is what we solved above, and I separated them. But you do not necessarily have to separate them. You just have to make sure that whatever you do to one side of every inequality, you do to all sides. So in this case, we want to get the p in the middle. So we would add 6 to get rid of the 6, but we have to add that on all 3 sides because these inequalities divide them into sides. That goes away and we're left with 3p in the middle. -36 plus 6 is a -30, which is what we had in the very beginning. And -15 plus 6 is a -9, which once again is what we had in the beginning. Once we need to get p by itself in the middle by dividing by 3. If we divide that by 3, we have to divide all 3 sides by 3. That leaves us just a p in the middle. -30 divided by 3 is a -10. -9 divided by 3 is a -3. So we have two inequalities we have to graph. We've got this one, which is written in the correct form. P is less than or equal to -3. And then we have this one, which we have to rewrite. Starts off with -10 is less than p, but we need to rewrite it with the p in front. Open parts towards the p, pointy parts towards the 10. And just like it was in the original inequality, we have a -10, a -3. P is greater than -10, open dot. P is less than or equal to -3. Less than's go in that direction, and we're done. All right, here's another one that we can simply solve all together. If we're adding 6, the opposite is to subtract 6. So that goes away, and we're left with x is less than or equal to and is greater than or equal to. 11 minus 6 is 5, and 6 minus 6 is 0. So our two inequalities are, we'll take this one first because it's written correctly. Whoops. X is less than or equal to 5. And then this one, we have to rewrite. Originally, it's 0. Oops. Sorry about that. It is 0 is less than or equal to x, but we need the x to come first. The open part is towards the x, and it still is. The pointy part is towards the 0. So those are the two inequalities we need to graph. So we need a 0 and a 5 on our, oops, a 0 and a 5. 1, 2, 3, 4, 5. X is greater than or equal to 0, so we'll put a solid dot, and the arrows are going that way. X is less than or equal to, solid dot, and the arrows going this way. So once again, they intersect. All right, and that is it. So get started on 4.1 and have success. And rewatch this video as many times as you need.